In this video, we are going to see about the radian and degree measure which we use in the important topic trigonometry. We'll be learning about how to describe an angle, how to use radian measure, and also how to use degree measure, converting degree to radians, radians to degree, and also the real life applications. The Greek word trigonometry means measurement of triangles. Trigonometry deals with relationship among the sides and angles of a triangle. Now, with the development of calculus and physical science, it is viewed as the relationship between a function and a set of real numbers. So the angles is nothing but a relationship between the functions and the set of real numbers. The application has got wide range. It is used in sound waves, light rays, planetary orbits, vibrating strings, which we always use in physics, pendulums, and also orbit of atomic particles. Let's first learn about angles. It is when we take a ray from a fixed point, and if we rotate that ray, the angle is the measurement how it is rotating from a fixed point. See, the ray, when you rotate from a fixed point, you get the angle, and the initial one is called the initial side, and then you have the terminal side. So this is the angle, which is the measurement between the initial line and the terminal side. Sometimes you may also have the initial side which coincides with the x-axis, and if a ray is rotated through an angle, this is called the standard position. So when you're taking the initial line which is along the positive side of the x-axis, and if you rotate a ray from that line, then this position is called a standard position. Now, if you take this angle is your positive angle, and if you're taking the angle between the positive side of the x-axis and the terminal line, this will be your negative angle. So you have a positive angle and a negative angle. Usually, the angles are represented by the alphabet, Greek alphabet, alpha, beta, and theta. So we use this type of symbols, alpha, beta, or theta. Now here in these two diagrams, you have alpha, beta, and alpha, beta is represented. Sometimes you can also have angles of this form. See, suppose if I have this angle can also be represented by this theta. So if you have got two angles alpha and beta together such that this total angle is 360, then they are called coterminal angles. So how to measure the radian measure? When you're trying to measure an angle, we always measure it from the initial point to the terminal line. The initial line is the positive side of the x-axis in this diagram. See this arrow given here? So that says that it is measured in this direction. And this anti-clockwise sense, counterclockwise sense, is always measured to be positive. This only is positive. So this arc length S equal to R when theta is 1. It's mainly because the radian is given by theta equal to S divided by R, where S is the length and R is the radius. So if I have a complete circle, I know that the length of this circle, which is nothing but the circumference of the circle, if the arc length, the complete arc length is the circumference of the circle, which is 2 pi r. So your S will be 2 pi r. So in this, when you plug in, your theta will be S divided by r, and your S is 2 pi r because it is a complete circle. That divided by r will be just 2 pi. Your theta will be 2 pi if I take the complete circle. See, if I take the complete circle, 2 pi will be theta. And what is 2 pi? 2 pi is 180 degrees. That's what we usually say, but we talk about the radians. The radians is 2 pi will be approximately 6.28. So your pi is approximately 3.14. What is this symbol? The symbol here means it is approximately. Because this is actually, there are some more values here, and here also I have more values. But I'm taking correction to 2 decimal places. So pi is approximately 3.14. or 2 pi is 6.28 if you are writing that as a radian measure. Otherwise, if you take that as angle, that will be 180 degrees. And in this, we have the first quadrant, second quadrant, third quadrant, and fourth quadrant. If I'm trying to find the angle which lies in this first quadrant, so I have to measure this angle from this point to that. So the angle can vary from anywhere from 0 to 90 degrees. What is 90 degrees? 90 degrees 180 divided by 2 or pi by 2. So it varies from 0 to pi by 2. If I take this rotation, theta varies from 0 to 180 degrees because this is the angle above the horizontal line. 180 is pi. So this complete angle will be between 0 to pi, or just in the second quadrant alone, it will be between pi by 2 and pi. The same case with the third quadrant and the fourth quadrant. 3 pi by 2 is 270 degrees, 2 pi is 360 degrees. So since we are talking about the coterminal angles are angles such that the total angle is 2 pi, that is when you complete one full circle, then the angles, if this one is alpha, if this complete angle is beta, then alpha plus beta will be 360, or alpha and beta are called the coterminal angles. Sometimes you can also say the angle added with 2n pi will be coterminal angles, because if there is an angle, when you repeat this 2n pi, when you add 2n pi, it comes to a complete circle. So you got those two angles to be coterminal angles. Now here we talk about the coterminal angles and how to sketch the coterminal angles. Whenever you have a positive angle, any positive angle, you have to subtract 2 pi from it. See, this is a positive angle. You have to subtract 2 pi from this. So when you subtract that, what is 13 pi by 6 minus 2 pi? 13 pi by 6 minus 2 pi. 2 pi is the same as if I want to have the denominator as 6, then you multiply 2 pi by 6, so that will be 12 pi by 6. 12 pi by 6 is nothing but 2 pi. And when you subtract this, isn't it pi by 6? So this 13 pi by 6 and pi by 6 are coterminals, and that's what is shown in this figure. See, pi by 6 and 13 pi by 6 are coterminal angles. If you have a negative angle like theta is negative 2 pi by 2, you don't subtract but you add 2 pi. In your previous, you subtracted 2 pi, but now you are adding 2 pi. So again, those two angles, your negative 2 pi by 3 and 3 pi by 2 are coterminal angles. So you should remember both. If it is negative, then you add. If it is positive, then you subtract. So this circle gives all different measurements when it is 0 degree, 30 degrees, 45 degrees. So you can just see how these values are. 30 is 1/12 of 360, 45 will be 1/8 of 360. So you can easily construct points on a circle like this. And this is a comparison where you can convert degrees to radians and radians to degrees. This is like a formula you should remember. And also how you are relating radians to degrees. Pi degree is always 180 degrees. So try to remember these three formulas. This is a conversion between degrees and radians to degrees. You can make use of those three formulas to convert degrees to radian measure. So 135 degrees will be 135 multiplied by pi by 180, because when you convert degrees to radian measure, you have to multiply by this pi by 180. And when you simplify, you get that as 3 pi by 4. Second question, if you have 540, then again 540 is multiplied by pi by 180, and your answer is 3 pi. If you have negative 270, that negative 270 degrees multiplied by pi by 180, so it is negative 3 pi by 2. So you have complementary and supplementary angles like 360. Here complementary angles, if you add the two angles alpha and beta, it is 90 degrees. Here when you add alpha and beta, the sum of those angles is 180 degrees. Here alpha plus beta is 90 degrees. In this case, your alpha and beta, when you add, you get that as 180 degrees. You can try these examples to find the complement supplement of this. First one, if you are trying to find the complement, you subtract from 90, because only when you add these two, you get the angle as 90. So if you're trying to find the complement, you have to subtract from 90. Supplement, you subtract from. Now let us find the complement and supplement for 148 degrees. This 148 is greater than 90, so that there is no point in subtracting 90 minus 148, because if I subtract 90 minus 148, it will not be positive, it will be negative. Complements and supplements are always positive, so it has no complement. But you can find the supplement by subtracting from 180. 32 degree will be your supplement. What happens when I have an angle of this form, 2 pi by 5? So for complement, I subtract from 90 degrees, isn't it? The 90 degrees is nothing but pi by 2. So you subtract from pi by 2. For supplement, we always subtract from 180 degrees. Your 180 degrees nothing but pi. So you will be subtracting that by pi. So in this video, we talked about the radian and degree measure, how to calculate the radian, how to calculate the degree measure, and also the conversion from one measurement, degree measurement to radian, or radian measurement to degree measurement. Thank you for watching this video.